I welcome you all for the day 5, session 2 of Atal sponsored 5 days faculty development program on augmented reality and virtual reality. This session will be continued by Neelagya Mande, consultant, hardware society, on the topic designing applications and building AR and VR mobile apps. I request Mr. Neelagya Mande to take over the session.
Thank you. As stated, I think there was a mix-up in the session. So this will actually be the testing and CI/CD for Unity. So let me share the screen. I hope it's visible. Okay, so this session will be mainly around testing and CI/CD for XR. These are part of different extreme programming practices, extreme programming or agile practices that we follow mainly at ThoughtWorks, and these help us design and build applications that are more consistent in its quality as well as consistent in the delivery timelines. So we'll look through both of these practices in detail, starting off with test-driven development or TDD. Now, TDD is a particular practice so which states that every piece of code that we write should have a certain amount of test for it, should have a certain test coverage to it. Now, why is testing important? Mainly to maintain the quality of an application. So anything that has not been tested uh, might have different bugs or different scenarios that we might not think about. But once we write the test, we can understand that there are certain breaking points. Right. Manual testing leads us to different user experiences and understanding of the user experiences. But writing automation tests is how we can go through the different edge cases that are hard to implement. So the TDD test cycle is something like this. It's a red-green refactoring cycle where we start off with writing a failing test for the feature that we are developing, followed by fixing of the test, and then refactoring your code. What refactoring means is that reorganizing your code and setting it up in such a way that it's way more readable for any user, any other developer who is going through the code, as well as to make it more optimized. Now, we do this three-step process, every step of development, leading to higher amount of code coverage and thus like better written code. Also, there are three different levels of testing. You have unit test, integration test, and functional test. Now, they three form the what is called the test pyramid, which simply stated means that you write more number of unit tests, which essentially builds up the foundation of your testing framework, followed by a medium amount of integration tests. Integration tests are tests that see the integration between different components inside of your program. So if you have two different APIs or two different classes communicating with each other, integration tests are meant to test those communications, while unit tests are meant to test singular modules of your programs, like a singular class or a singular API, how they interact with the inputs and outputs. There are multiple different ways in which unit tests are done uh, by using different methodologies like using mock, stubs, spies, and all. We'll look into those in a bit detail later on. And finally, we come to functional tests. Functional tests are essentially your end-to-end tests, tests that see the entire flow of functions inside your application. Functional tests can also be thought of as user journey tests in which we follow the journey of a user. Maybe it's a form kind of an application that we're building. So filling up the entire form and hitting submit for it to get registered on a server, that would be an end-to-end test. That would fall under your functional test. Now, apart from these three, there are many more different types of testing, like smoke testing, experience testing, manual testing, exploratory testing, and all that. but their amount is much more minimal, and most of them fall under manual tests. In this session today, we'll look at mostly automation tests that we write as part of code, not how we do physically. So unit tests are normally written by developers themselves while developing the functionality, while integration fall on more of a gray area. It's both the quality analysts as well as the developers who develop integration tests depending on the feature. And the functional tests are mostly responsibilities of the quality analysts who work on the same project. So to get into specifications of Unity, there are two major types of tests in Unity that are edit mode tests and play mode tests. We'll go through what is how the test runner works and where to find it as well. So edit mode tests are tests that run on the editor's loop. So Unity is a running program, right? And it differentiates very less between its play state as well as your edit mode state. What it means is that any code that you write can run both on the editor as well as as a form of an application. The code doesn't really vary. Similarly, the tests aren't that varied either. The code themselves are written same, but they can run in two different modes. Edit mode just means it will run as a separate process for the test, and play mode means that it will run as a standalone or inside of a coroutine of the application loop. The application loop here means the player itself, that is your uh, application's lifecycle functions will run through it. Unity functions such as start, your fixed updates, on destroy, those kind of calls. So there are also two separate annotations. One is the test annotation, which means that your test will run as a single process and as a single step rather than a continuous process. While there are unity tests, which the annotation essentially means that your test will run as a continuous process rather than a one-step thing. So we'll go through these in details in the demo section. So what I have here is a very simple application, similar to the one that we went through earlier in the sessions. So this is also a Google VR project. There is a very basic setup of a player and the camera. And we have three different buttons here corresponding to three different colors and a cube. And each of these buttons do a simple function of changing the color of the cube. Okay. So given that is our application, there can be different ways of approaching the like development of the application. So we'll try the test-driven development approach and see how it affects development, how it like increases the code coverage. So let's go through the different scripts that we have. The major script that we have is color picker. So color picker is a very simple script which has a few APIs. The major being get change color, and it has two types of signatures. We'll go through the signatures later on. But in true TDD fashion, we will start from scratch. So we'll remove all of this, and we'll try rebuilding this entire structure in a test-driven development fashion. This is also a test file. We'll also clear this up. Okay. So every test that you write will be run on something called the test runner for Unity. Once this loads up, yeah, the test runner for Unity. Currently, we shouldn't be having any tests. Yeah. Currently, it's empty. We do not have any tests here. So this entire assembly is empty. You can get the test runner from Windows General Test Runner. This will give you this tab. And in order to create a new test runner assembly, what you can do is right click, go into create and go into testing. This will give you a test assembly folder. Once your test assembly folder is built, you'll get to add different test scripts. I already have an assembly set up here, and this is the assembly file. Now, in order to refer to the code that is in your actual application, you will need a reference to that application's assembly. This reference assembly is where you attach the reference. So inside your test assembly, you simply drag and drop the reference to your code assembly. And now you would be able to access your code from the test files. So let's go into developing this test as well as the functionality. So we'll start with a very simple test. Before we write any test, there would always be a test file. For our case, it's the color picker test. And for every test, there is a certain amount of setup that goes into the test. For this particular test file, we have a very simple setup. We have a sample object, a color picker instance. This is the class we are trying to test, and a cube that it will affect. This is a primitive cube that we are creating, and we'll assign it as the color pickers object to color. Now, if you look into the APIs for this color picker class, it has a few exposed fields, that is the object to color, and a few exposed overloads, essentially APIs, functions. There's the change color with two different signatures. So we'll start by testing this signature, this string one. So let's say we want the functionality to start with some specific color, like for example, red. So we'll start by writing a test. So for this one, we'll use the unity test. We'll give a name to this test. So should set gives color to red, for example. So now every test is divided into three parts: the given, the when part, and the then part. So given is the setup that you need to do in order for the test to run, the environment in which your test will be run. Now we have a specific setup done. We'll see if we need anything else or not. When is the condition that you're trying to test? So our condition would be something like color picker dot change color to something like red. Right? That is our conditional thing. Finally, then is the part where we want to assert whether the functionality that we did, whether it actually took effect or not. So our simple assertion would be something like assert dot r equal. Now we'll need the cube's color. So the color component will be inside of its render component. Rendered material color, and we'll assert this with the color red. Color.red. So in order to make sure that the color wasn't by default red, we'll also set this color to something else at the start of the program. So at the start of the test, this is our set. So we'll take the color to be something like black. This just makes sure that it doesn't get mixed up from any residual value. So this is our very basic test. But as you can see, this function is still empty. So this is what we would call a red test. So now if you let the test runner load up, you can see that we have a single test. Once we try to run it, it fails. And it gives you the reason why it failed. Method returning bird. Okay, so this can be a simple test actually. This doesn't need to be on a coroutine. Yeah. So now we can see that it failed for the right reason. It expected a color that was like red 1 and alpha 1, while other 0, which means red essentially. But what it got is this black color, which is 000 alpha 1. Right. So that is the red part of the test that we talked about, writing a failing test. Now we'll try to fix the test. Now, since we already have the test code written, the minimum amount of code that is required to fix this test is something like material dot color equal to red. Now, regardless of whether this logic is correct or not, TDD says that you write the minimum amount of like actual code that is required to pass that test. Why do we do that? So that there is enough tests to justify the logic that we write. So this is the minimum code that should get rid of this test, right? Or make this test pass. So let's try it. Okay, this needs to get the start component. Okay, so since it was dependent on this start function, which is where the material would set up, the material was not being set up as this test was not running on any core routine. This test was a static test. Now, in order to get over that problem, we can use a unity test. But unity test will only run with enumerators. What are enumerators? Enumerators just means that this will run as a process over time and not instantly. So once we give the output as being an enumerator, we'll also have to skip a certain frame. So we'll do a yield return null. This just states that we'll skip a frame after the setup is done. This skipping of frame is what we'll call the start function, which will set up this material reference and thus will not get the null pointer exception here that we got here. So now if I run this, yeah, the test passes. So even though the logic is incomplete, our test passes, which means that we'll have to repeat this cycle of red-green refactor, right? So instead of just one test, we'll simply duplicate this test. And now, instead of sending in red, we'll go for some other color, let's say blue, right? Our given will be same. We'll still leave it at a static color like black, but here is where we'll change it. So now we have our second failing test. So once this loads up, we'll get another test. And if we run this, we should get the red as passing while the blue as failing. And the reasons are pretty simple. It's still, it expects a blue color, but it's getting a red color. So now our logic needs to evolve. So depending on the string, whether the string is, whether the color name is red or blue, we need to decide whether we should go for the color red or the color blue. So we'll go for simple else ifs or even else because that is the minimum code required. And thus we would have our logic, right? That is sufficient enough to get through this cycle. Right. Now let's say we went through multiple of these cycles and we have a lot of tests. So once we get all of those tests done, we would go into the third part, which is the refactoring. Refactoring is where you would optimize and clean up JPO. So for this cleanup, we can do something like turning this into a switch case, for example, for essentially better optimization. So instead of this, we'll take the color name. We'll set up the different cases, red, green, and blue. Right, and that would be fine. Now, that would essentially build up our basic uh, basic functionality. So let's just check that still holds true. So that goes true. So this is a test for a class which is very much independent of anything else, right? But sometimes you would need to test for classes which are not so independent, but they are dependent on other classes. For example, I'll revert this code back to what it was. So other classes might be, it might be dependent on other classes. For example, let's say there was an API, like an iCustomColor. This might be an API that is being sent from, let's say, your server, which at runtime determines the kind of UI you want to display for the users. Let's say the kind of color effects that someone put on one of the stickies that they added on the board, right? That comes from the server and is not under your control. Sometimes it also happens that these APIs are not yet built, but you have to write code as if the APIs are already built, right? So I have this interface, but as you can see, there are no implementations of this interface. So this function is never implemented. So it has no actual code running behind it. So how would you write a test for something that is not even present, something that is not yet built? For that what we use are called mocks. Now, mocks are essentially anonymous class kind of things, structures. So I will revert all of this back. Okay, we'll leave this there. So we'll start writing the test after this. So mocks are essentially structures of classes or interfaces that are not yet built, essentially proxy classes. So we'll write a test for this new API that is going to be built. So we'll write a new unity test, same enumerator. Say as required. Okay, and let's say we have an instance of this iCustomColor. Right, and we have our API on the color picker, which takes this new color object, right? And we expect the color to be some specific color. So this becomes our when, and this becomes our given. So given that we have a custom color, which is coming from some API outside, some server, or any of the SDKs, and you need to change the color accordingly. And let's say the expected color was something other than this, something like yellow, which is good. But since there are no implementations of this class, this object is currently null. Now, to get around this problem, we can't really create a new object, but essentially what we can create are stubs. So I'll be using a plugin, or you can see say a library called nsubstitute. I have the assemblies here inside of my test assemblies, and I'll create a stub, or I'll create a mock for this class, iCustomColor class. I'll say this will be a iCustomColor. So now what I have is a object for this class, a class that has no inheritor, no implementation. This is the concept of creating proxy objects or substitutes or mocks. Similarly, you can add implementation to these mocks. So, for example, color dot get color, whenever we do this, we can add that it returns a certain color, right? Now we know the return type is a color. So let's say it's yellow. So now we have a stub. Stub essentially means like functions and functionalities of a proxy object being filled by proxy functionalities. Like this doesn't do any server call, right? This is still empty. This is only still just the description. But I am returning a different value out of it. This is the concept of stubbing. Okay, so finally we need to still skip a frame because not okay. So finally we will also skip a frame just so that it runs on a coroutine and that start function gets called. And now we have a function of an API that's never been implemented. So let's see how that function runs. Once this loads up, yeah, we have this new function. Sorry, I should not have the actual implementation. So normally we would write the test first and the implementation later. So normally we'll start off with a failing test. And we'd have the failing test because we wouldn't have the right colors in the objects. Once we add the functionality back in, the test will run. So this is the concept of mocking and stubbing. These are how you would write unit tests. But apart from unit tests, there are different types of tests that we were also discussing, essentially integration and functional tests. So let's look at how we can write an integration test for this particular scenario. So in this particular scenario, there is a certain integration between the buttons that are present inside of the scene and the object that is being colored, right? So in order to set up an integration test, we'll write a new test file. So let's say this is an integration test. Let's open it up, and here what we'll do is we'll set up the scene. So I'll again add the one-time setup. This is the annotation for any pre-testing setup that you need to do. So public void setup. This is where we'll try to. So we have this cube, which is of the name cube. So we'll try to find this object, and we'll see if the buttons and the changing of the color of this object are linked or not. So the buttons are inside of my canvas, and they are called red, green, and blue. And we'll try writing a test for this red button, whether clicking this red button actually changes this cube's color. So we'd need variables to hold those values or references. So we'll start with a game object cube. Okay, we'll start with by loading a scene. Scene manager load scene. So every test that runs normally runs in a different scene. So in order to load this specific scene, we'll just have to call the load scene on the main function, and that will load that scene. Now we need to get the object. So game object dot find, we'll say cube, and that will find the specific cube we are looking for. And also we need to find the different buttons, red, blue, and green, right? So let's say we have a button. Yeah, let's just say it's red. So do the same thing, we'll find the red button and we'll take the button component of it. Finally, in our actual test, should color cube to red. On clicking button, for example. So we'll still have the 3 steps, the given, when, and then. The given is this should be enough. When would be something like red button dot on click dot invoke. So I'm invoking the click. This is my when. And what we'll assert this against will be that our cube will get component the renderer, material color is the color of the cube, and assert it against the color red. Right. Okay. All brackets are closed, and what this should essentially do. Okay. This cannot be void enumerator. We'll skip a frame just so that it runs as a process. And okay, so we should have our test ready. So it comes in as a separate file called integration test, and this is our test. Okay, one time setup and logs. Okay, so it's not added here. So it can only load scenes. Okay, that's added. Could not be loaded because it's been added to the build setting. Should have this. Object reference not set to an instance of an object. So yeah, I have to open the source code. Okay, some reference is missing. Okay, so it's having some issues to find that object, but essentially the process remains the same. So once we find the objects by its names, we get the components and run the functions and assert against the values. I'm not sure why this is not functioning at this point, but that's how the process is. So that's how your integration test will be. Now we can take this a step further, for which we'll look into a different project. And this project is similar to the one that we worked on today morning, the VR project. This is not actually using Google VR, but using Cardboard's own SDK. If I can show you using Visor how it actually looks, let me try that. What is this instance? So essentially how it looks is like this. I just put it going down. Yeah. Yeah. Essentially what it is the old kind of thing. You'd essentially click to move around, and there are these crystals that are in the sea. If you tap on any of that, that would get collected. Very basic structure, nothing that we haven't coded to the morning. Right. So given that is our project, what we'll try to do is write a test to automate a lot of these functions. Now, how that would be done is, for this project itself, I'm using a certain like external API called Arium. This is a plugin slash library. It's a very simple library which contains a few like action performing things. So in order to write any tests, what we would essentially do is try and find all of the collectibles that are inside of a scene and try to collect all of them in an automated fashion. So I'll edit this new test file. So we'll start with the same structure. This acts in the same way. We'll load the scene min, and we'll start with the same structure. So given, when, then. And given that we have a set of collectibles, so I'll make a collectibles array. Now, collectible is just one of the classes I am using to represent these cubes or these gem kind of structures. Okay. So here what we have are the different objects. So I'll use find object of type. Okay, is my screen still shared? Sorry, I think the sharing screen. Yeah. So game object or find object of type. So we'll say collectible. And this will give us essentially an array of collectibles that we want to work with. And for every collectible, what we'll do is we'll call the Arium functions to perform action on them, like let's say a Unity click. On these collectibles. Dot game object. So essentially what Arium will do, it will go through each of the collectibles themselves and start clicking on them. And thus your user will start interacting with those actual objects inside your scene. So I'll try not to write the entire thing. I'll just show you how this runs. Let me also comment this out so that we don't have compilation errors. So if we go through one of the tests, it will essentially move to different positions and start interacting with different objects. Similarly, if we ran it on the entire array of all the objects, it would move to all of those objects interacting with them. That is how we would set up an automation. So that's about testing. If anyone has any questions on testing, let's go through them now. After that, we'll go through the next part, that's CI/CD. I hope I was audible.
Yes, sir, you're audible, sir.
Yeah. Okay, good.
Participants,
If anyone has any questions on testing, let's take them now.
participant, if you have any queries, kindly unmute yourself and you can interact. Sir, I think there is no queries.
Yeah.
You can continue, sir.
Okay, sure. Okay, so the next part of the session is all about continuous integration and continuous delivery and deployment. So CI/CD is one of the agile practices that are used to make sure that whenever we are trying to deliver some product or application to our clients, is the actual delivery process is much more smoother. So let's look at these terms individually. So when it comes to continuous integration, it's mainly about integrating the code at a continuous basis. So you'd normally have a shared repository where different teams of developers or different developers even would push their codes to it. Normally, you would use version control methods like Git or for Unity itself, there is a method called Unity Collaborate. You can use either of them. Collaborate has their own features of continuous integration and deployment as well. But for our example itself, we will go through Git. So it essentially automates your building and your testing process. So all the tests that we written earlier, they would essentially run on a server rather than on your local machines. So obviously, before you push the code to the servers, you will run the test once on your local machine just to make sure that the build doesn't break. But apart from that, normally all of the testing and the merging of code happens on servers. This part is called continuous integration. Right. Now, CD is divided into two different terms, that is continuous delivery and continuous deployment. Continuous delivery means that you have the entire delivery process automated, right? What automated means is that whenever you click a button, your app essentially builds an APK, your project essentially builds an APK and pushes it up to, let's say, your Google Play Store or wherever you are trying to hold the application. While continuous deployment means that this continuous delivery process is not triggered by a button, but it's triggered automatically. What do you mean by triggered automatically? Things like, so bigger industries or bigger applications like, say, Google's own server or YouTube, for example, they have things like continuous deployment, where nobody is manually like pushes a button to deliver the code. The code is mature enough to be pushed continuously. The moment someone hits it, runs to building CI/CDs. The major things are, firstly, you don't have as many bugs in productions as you'd have if you went for a manual merge kind of thing. Since all the tests are automatically running on your CI, your continuous integration platform, you don't really need to think about bug. If there is a bug, if there is a failing test, your build will not even get processed. The APK will never be built because they will be like struck. It's also easier to build since all the process, yes, the process setting up do take some time. So you have dedicated time investment to set up the your build server and your build pipeline. But after that, every time you try to integrate or set up your build or push your deliverables to your stakeholders and your clients, it's a much more streamlined process. You have early and focused resolution of broken builds. Since you're pushing, every time you're pushing, the tests are running, you have a constant history of which of the builds were green and where in which particular commit did your build essentially break. Then you have reduced testing costs. Since there are hundreds of tests that are running on the CI, nobody needs to manually test each build. Like there is an amount of regression testing that is required during delivery, but apart from that, your tests kind of run instantaneously with your push. The QA team, the quality analyst team, can focus on improving of quality and not testing individual builds. So normally in a day, you will have multiple builds, like 4 or 5 builds, depending on how frequently the developers are building, right? But the QA team doesn't need to focus on that. They can only focus on the end half of the delivery, where you need to actually do the CD part of things. And they can look into how to improve quality, like performance and things like that, rather than testing each build manually. It also reduces the release complexity. Since your CD is already set up, you have just one trigger option. You hit one trigger build or some kind of a button, and that builds your entire APK and pushes it out to the cloud and all that. And finally, you have no pausing for development. What this means is that no developer needs to stop and merge all the code manually. Most of it happens at a continuous basis. So you don't need to put dedicated time for releases. But there does go some amount of time, won't lie. Accelerating the feedback loop. Whenever something gets delivered, if it runs through the entire process and reaches your end customer faster, you get faster feedback. Essentially, you can fix your builds much faster and improve on quality rather than waiting for other people to intervene and make changes. So with that said, since we have a bit of an idea of what CI/CD is, let's try setting up a CI/CD. So for this, I will be using the same project. I will clean this up actually. So that should clean up my project. So we'll try doing it with this same project. It has a few tests pre-written, 5 tests or so. Let's just do a sanity check. This should be removed, and that failing is fine. So this is the project we'll be working on, and I have a local setup of a CI. So this is Bamboo CI, but the concepts run on any kind of CI, whether you are choosing Jenkins or Circle CI, Bamboo CI, or Go CD. The concepts run the same. I'll also close this just for performance. Okay. So we'll start by creating our first plan. Now, every CI process is broken down into. Where did I get blocked? I think I put it as notes. Hoping I remember the password. Okay, so every CI process is broken up into certain parts. There is a plan, there are jobs or stages, there are tasks. So we'll go through the individual hierarchy as we build it. So we'll build a CI from scratch and see how we can link everything together. So we'll start with a project name. So this is where the CI is getting configured. We'll leave the project description, one can add it, of course. Now there is a plan name. So every project might have multiple plans. So we'll just configure one of the plans. And every plan would be associated with a version control system. Now there are different version control systems, but for our use case, we'll go with Git. And the CI/CD that we'll work with, display name, CI unit test is fine. And repository, will use some repository, the same that we are using there. Now, we also need to pull those builds or commits that are pushed to the CI. For that, normally you would use a SSH private key and set it up in the CI machine so that nobody has to put their own username and password. But for our use case, just to show in this demo, we'll go with the trusty username password. Okay. Yeah. I'm hoping that works. And there are different branches to your version control. We'll use the master branch. Let's just test to see if this is correct. Okay, so the connection went through, and this is how you set up your plan. Now, once the plan is configured, so each plan consists of different jobs, and each job has their own task, right? Now, each of these jobs can be inside of different containers or agents, right? So how CI/CDs are normally configured is that you have a master, which is your distribution system, which essentially coordinates or manages your different projects, your different plans, and different jobs. And you have agents. Agents are your actual machines on the server that run your different plans and different jobs. So currently I have two options. One is to run on the agent environment itself, which means whichever agent gets configured, that agent will run all of these jobs on its own machine, that is inside of its own drive. There is also the concept of Dockerizing your agents, which essentially means that rather than running the job inside of that singular agent, it will Dockerize a space. What Dockerization means is that cutting out a space like a small virtual machine and running all your processes inside of that Docker. Now, Dockerization is important, like useful, mainly because you can move those Dockers around from agent to agent or even SSH into them to see what processes are running or failing, right? So for this case, both my server as well as my agent are my own machine. It's running locally here. My Bamboo service is running here, right? And every plan that you have or job that you have comes with a pre-configured checkout. So this essentially pulls the repository data and keeps it onto your machine. Apart from this one task, you will have to add different tasks to it. So we'll go through those tasks one by one. The first major task that every CI/CD requires is the running of tests that we see in the continuous integration. So I'll add a script task to this, and we'll just say it's a test. It will be shell, it will run inline, and I will pick up the actual code because nobody's going to remember this. But I will explain through what this actually does. What it does, it picks up my Unity reference or Unity installation and runs a particular command on it. It's called run test. This run test command is the one that tells to the Unity instance what to do. Run test just simply means that you need to run all the tests that are inside of this repository. Apart from run test, there are other parameters like your test platform. This essentially says the type of test we want to run. As we saw here, saw in the previous slides, that there are the edit mode as well as the play mode tests. The play mode test is the one that is configured in this project, so we'll do it as play mode test. Similarly, there are other parameters like your test results. I am saving my test result in my Bamboo working directory itself in the name of results.xml. This is just the XML file that would be generated from this. Similarly, I will print all the logs here itself, that is why the underscore, and run the entire process in batch mode and no graphics. So normally on servers, the thing is that you won't get any display. Normally they are just like server machines. You don't actually have any monitors or even any input devices attached to them. They're just CPUs. So in those cases, if you don't run it on no graphics or not in batch mode, what will happen is it might prompt for yes and no kind of a UI. Like, do you want to build this or any process or loading progress bar? It will try to display that. And if it is not able to find any output device, it will fail. So it's always appreciated to just run it without any graphics. So the Unity instance will run, but not as only as a process. Apart from this, we also needed the project path, which is the path of my Bamboo working directory. This essentially sets up our test task. Now you might think, where would you find all of these parameters and how would you remember all of this? Well, Unity manual is your best bet. This is where you will get all of the different arguments, and there are loads of arguments, not just those. See a few more, but those are your major arguments. So as you can see here, in quite a few of these, we are using this bamboo dot some variable name, right? These are called your environment variables, and each of your agent will be configured with certain amount of environment variables. Some of these, like working or directory, are pre-configured, while things like your Unity path is a custom argument. We'll look into how we can add arguments later in this session. So with that said, we'll set up our first task. Right, we have our test task done. Now this test task was like writing all of its test result inside a result.xml. And result.xml, being an XML file, might not be very readable for users. So just for like readability's sake, we'll add a new task called NUnit parser. Now internally, Unity runs its tests on a NUnit system, and this NUnit system is the one that could generate that result.xml from this test task, and it will get stored in the results.xml file. So this NUnit parser task will pick up that file and display it in a more readable fashion. So task description, we don't need it. And that essentially configures our testing part of our CI. The next part that we need is the building of an APK out of this file. So we'll add a new task. This will also be a script. And let's say this is our build APK. Similarly, we'll copy the code because nobody's going to remember all of that. But so this is a bit different of a task. So similarly, we'll pick up our Unity installation. We'll tell it which project to build. And there is a special argument called execute method. This execute method is an argument or is a parameter that takes a single argument. Everything that is with a hyphen is the parameter name. Everything after that is its corresponding argument. Okay. So what it will take is a function signature, essentially. So build command dot perform build is an editor script that is inside of this project. So inside of my assets for this project, there is a editor assembly. This is only for editor, and that contains this build command class. What this build command class contains is this perform build function. Whenever, and it has to be static function, by the way. And whenever we call any function on a project using this execute method parameter, it will tie up with your editor static functions of the same name. So the name being build command dot perform build, and it will tie into this. Now these functions can have their own arguments and parameters, which you will get via this get argument function, which essentially boils down to this. So your environment get arguments and just split that arguments into different parts. That being said, for our case, it takes like two major arguments. One is the custom build path, where the new APK or whatever file it generates will be set, and the build target, the target it's going to build. Ours is by default on Android, so I don't think the actual function even has that. So custom build path essentially goes into this, the bamboo working directory, followed by build underscore the build number dot APK. This is our file name, and we are avoiding the other argument. The other argument being build target because it defaults to Android. So we'll just build an APK out of it. Finally, the same arguments we are using, log file to be instantaneously there, like wherever it runs, it should show the logs there itself. And finally, you have batch mode and no graphics for the same reasons. So what this will generate is your APK. And here also we can see that we are using the Unity path variable or environment variable that is not configured. Now you could configure the environment variables here, but this would make it task specific. And since this environment variable is being used in multiple tasks, writing it here means that you'd have to do the same for other tasks that you use. So for now, this much is enough. So it's a shell script, it's an inline script that will run, and these are the scripts that it will do. So we'll save that. Now, once this is all done, all of your jobs and tasks are configured, you can hit create and that will create the new plan and also start running a build. Now, this build by itself is bound to fail mainly because we haven't actually set the Unity path. So I'll just stop the build for now. And we'll start configuring the environment variables that we need. So once we go into the CI, we'll go into the project settings, and inside of variables, we'll add the different variables that we need. So I think it's Unity path. Let's just check. Yeah, Unity path is that, and this is my Unity path. So that's my Unity path that we'll be using. So just add it. And we have our Unity path variable configured, environment variable configured. Once that is done, it will run through and we won't have any issues, but currently it's missing something. So what it's missing is even if we build the APKs and build the results, they are not being stored anywhere. They're not being not even deployed. They're built, but they're internal to the agent machine. We aren't getting it out in any way, shape, or form. So in order to do that, what we need to add are artifacts. So each of these like jobs might have their own artifacts and requirements. So let's go through the artifacts first, then we'll go to the requirements. So artifacts are the things that come out of your build. So for example, let's say the test result is an artifact we want to generate. So we'll put it as test result as the name, and we'll put the pattern of the file that we want to take out. Now there are sorry, am I audible?
Yeah, now only audible.
Yeah. Okay. Did I got? I think I got disconnected. Okay. So yeah, let me continue. Let me know if you folks missed something. Okay. So I'll go through this part again. So anything that is marked as required is something that will cause the CI/CD to fail if that file does not get generated. And if it is marked as not required, the CI/CD will run even if that file is not prepared. So similar to the test results, we will add another artifact, which will be our build APK. And this time we'll set it as required, which means if APK is not built, it will fail. So this is where we're getting the required. So these are all the artifact configurations. Finally, we have the requirements. Now, requirements are the agents. So as I said before, every CI/CD server will have a centralized server, a distributor kind of system, and multiple agents. For my system itself, it's one agent, one server because it's the same machine. But normally you have multiple agents, and each agent is assigned with certain amount of capabilities. For example, you might be running in a ecosystem where there are agents that do not have Unity, but you are trying to build a Unity project. So it won't work if it doesn't have Unity, right? So requirements and capabilities are where you would say that, hey, I need these capabilities for this job or this process. This is where you would configure that. For example, I don't think it will show up as Unity, but essentially whether you need Gradle, maybe not some kind of process, it will get it as there. Like you need a specific version of Java that needs to be there. These would be set up at the agent level. Those setups I haven't done on this end. So once you hit exist and add, it will only assign the agents with the certain amount of capabilities to the job that you're trying to run. Otherwise, it will skip that agent and go to a different agent. Given all of your settings and all are done, normally you won't manually run the process, but whenever someone pushes any code to the actual repository, the process would run by themselves. But that happens over a time period. Like your CI/CD will check for any changes to the repository every 5 minutes or so, or some amount of time. That's variable and configurable. But since we are on a schedule, I'll just run it manually. So this process will run and it will take some time. If anyone has any questions till now, feel free to ask. So this is from the log argument. It's just printing all of the logs here. We'll go through all the processes. But if anyone has any questions till now, feel free.
Participant, do you have any questions? Please raise. Sir, I think no questions.
No questions. Yeah, here as we can see that the build is starting to run and the testing part is already taken care of. So once the build starts running, or if it is initiated by a certain commit, people can check the commits that it got initiated from here. Similarly, we can go through the detailed logs. We can view them or download them. Once this completes, we'll also have the artifacts, which is what we are waiting for. Okay, let's wait for the artifacts. Meanwhile, let's complete if anything is left. Okay, so in conclusion, what we learned today are the whys and hows of XR practices. Mainly, why would we need things like testing and CI/CD in our build processes, and how we would do it, how we'd go through the different types of testing, unit test, integration, and functional tests, and how we would incorporate that into our CI/CD build pipelines, and how that would make life much easier for development itself. So with that said, I think I can conclude. So I'm Larg Mondal, a consultant from ThoughtWorks, and yeah, that's about it. You can wait for the build process. I think it's already done. Let's just see if that forms the artifacts. Yeah, I think we got a green build. Cool. So as you can see, the shared artifacts come in here, both the APK file, I can download the APK. It came in as build_2 because this is a second build. It took the build number from the working directory. And you have the test result APK, blocking the downloads. Yep, we have the test result APK, which is the XML file that it generated. Now we can also go into details of the test itself. So here is where we would see the different tests, the individual tests itself. If any failure build itself was triggered by a specific commit, it would show up here, and artifacts are the same artifacts. Okay, with that said, I think I'd conclude my session. If there are questions, feel free.
Participants, do you have any questions? Please ask. Sir, I'm having one question, sir. After finish testing this using this software, after that we need to test using head-mounted display, right, sir? Actually, if we go to head-mounted display, directly we can install and check the APK. Is it so, sir?
Yeah, after you get this built, you can give it on a head-mounted display and test it out.
Okay, sir. Okay.
So the main drawback to that is testing on a head-mounted device is that given the number of builds that each day produces, even in our case, so we have quite a few builds for individual projects, and the QAs are very stretched out. And keeping those head-mounted displays on for around 4 hours or 6 hours a day puts a lot of strain. So it's easier to work on like CI/CD based things. Yeah. Any other questions? Feel free.
Participants can use chat box also if you have any doubt or questions. Okay, I think one more question. So thank you, sir, for this wonderful session. We gathered a lot of information related to our continuous integration and continuous development and testing of Unity, using Unity. The way of handling the session also very nice, sir. In this, the participant, I think the participants also enjoy your session well. On behalf of Department of Computer Science and Engineering and the coordinator of this FDP, I express our sincere thanks to you. Actually, you handled more 3 sessions. All 3 sessions are went very well, sir. Also nice. Also, I thank all the participants also for this passion and integration. Thank you all. Okay,